All right, this is from the NCEA 2 exam, the 2019 end of year Year 12 Algebra exam for New Zealand students. Let's take a look at this one. It requires you to have your pattern recognition software working in a fairly sensitive setting here, as there are two things really you need to notice. The first thing, which is the most obvious, is you've got a 3 to the 2n for everything except for this one here. And this one's a nice easy one to turn to the 3 to the 2n, because we know that 9 is equal to 3 to the power of 2. So if you've got 9 to the power of n minus 2, that's equal to 3 to the power of 2 times n minus 2, which of course is 3 to the 2n minus 4. 2 times n is 2n, 2 times negative 2 is negative 4. So nice and straightforward. And so what we're going to do is we're going to restate this problem, but we're going to substitute this expression for 9 n to the minus 2. So let's do that now. So here is the expression, here is the equation, 3 to the n, okay, 2n, what am I doing? Not good. All right, 3 to the 2n minus 1 plus 3 to the 2n plus 1. And I'm noticing here you've got a 3 to the power of something minus something, which really, by the way, and this is where this is going to come in a bit later, this is the same as saying, and I'll just put it up here, 3 to the 2n times 3 to the minus 1. Bases are the same, we add the powers. So we're going to express this one in the same way in a moment. Going to be slightly different, of course, answer, but the same thing, it's the same principle. Now this is 3 to the 2, and you'll see this in a moment, minus, and this is where we put in our new expression here, 3 to the 2n minus 4. All right, we're ready to go now. So now we're going to turn everything into this form here. And we're going to do it because we're wanting to factorize this. The moment we factorize, we can cancel. And we're working on the principle if the bases are the same and they're multiplied, you can add the powers. And that's really what we're doing here. This is the same as saying this thing here. So let's restate this. This is going to equal 3 to the 2n times 3 to the negative 1. Bases are the same, we add the powers. 2n minus 1, or 2n plus negative 1 is 2n minus 1. I've got a big plus in the middle, there it is. And now we're going to have 3 to the 2n, and we're going to have times 3 to the power of 1. Because the bases are the same, we got a 3, and 2n plus 1 is 2n plus 1. Same thing on the bottom, let's do the same principle. So we've got a 3 to the 2n. Now there's nothing else there, it's just itself. And then we're going to have, there's going to be something here, oh look, so let's now factorize this. Well, this is going to be a 1, because 1 times 3 to the power of 2n is 3 to the power of 2n. And we're going to have minus, and what's this one here going to be? This one is going to be, in fact, I'm not going to have a factorial. I'm jumping ahead of myself. I was just going to factorize the whole thing right there. But I think we'll leave that. We'll leave that for the next bit. I'm just having a bit of fun here. All right, so that's going to be a minus. There's one minus there, yeah. And I'm going to say 3 to the 2n. And this is going to be a 3 times 3 to the minus 4, because 2n minus 4 is 2n minus 4. Now, I'm noticing we've got bases of the same. Okay, so I've got, sorry, not just bases, we've got a whole lot of stuff that's the same. And this is a common factor, common factor, common factor, common factor. So I can take 3 to the 2n out. Now, what times 3 to the power of 2n makes 3 to the power of 2n times 3 to the 1? 3 to the negative 1. And what times 3 to the 2n makes 3 to the 2n times 3 to the 1? And the answer, of course, is plus 3 to the 1. So this thing here now expands to give the same as what we've got here. Now it's all divided by, now let's do the same thing again, 3 to the 2n, here it is, times. Now what times 3 to the 2n makes 3 to the 2n? Well, the answer is 1. And I've got a minus there, I'll put a minus there. what times 3 to the 2n makes 3 to the 2n times 3 to the negative 4. Well, 3 to the negative 4 is the answer. So now let's go ahead and oh, cancel. Look, that and that cancel. So now we're left with this expression here. And we've got 3 to the negative 1 plus 3 to the 1. Well, we can actually do it on the calculator, I think, pretty easily now. Let's go ahead and let's just plonk all of that straight in. So I had, I've got it in front of me here. I'm just going to read it off the page there, but I can't have it on the screen saying I was the calculator. Otherwise, I won't be able to see what I'm typing. Okay. So the top bit here I've got is a 3 to the power of, in fact, I'll do it in two lots of brackets. Here we go. 3 to the power of negative 1, yeah? And that's going to be plus 3 to the power of 1, yeah? And that is all going to be divided by, here we go, where's divide by, I'll put two lots of brackets again, 1 minus, another bracket, 3 to the power of negative 4, closing lots of brackets. And that is equal to 3.375. And there's our answer, 3.375. Now, fortunately on these calculators, you can push the button here, the FD, that means fraction to decimal button. Push that button there. Here we go, what do we end up with? And we can get 27 on 8 if you like. So we can say equals 27 on 8. Only if you want though, but ultimately anything like that would be a perfectly reasonable solution. So that's how I would express that. Hope that makes sense.